Okay, in this video we're going to talk about how to solve a formula for a given variable. Now in previous videos we've solved equations that look like this. 3x plus 5 equals 9. Something like that. We've been solving those. In this section we're not necessarily going to be given numbers like 3 and 5 and 9 in these formulas. They might be variables or letters. We might have an equation that looks something like this. ax plus b equals c, where a, b, and c and x are all unknowns. They're all variables. So you already know how to solve this equation, 3x plus 5 equals 9. What you might not know how to do is solve this equation, ax plus b equals c. What I'm going to show you is that solving this equation, 3x plus 5 equals 9, is really no different than solving this equation with the a, b, and the c in it. And we're going to solve both of these equations for x. And I'm going to go step by step through the equation that you already know how to solve and compare it to what we do with the equation that you may not know how to solve. So what's the first thing that you do when you're solving 3x plus 5 equals 9? Well, you could probably tell me that the first thing that you do is you subtract 5 from both sides of the equation. And we're not going to do anything differently with this equation with the a, b, and c in it. If we're going to try to solve for x, the first thing that we're going to do is we're not going to subtract 5 because we don't have a 5. We're going to subtract b from both sides. Okay, now what do we get on the left equation? The plus 5 and the minus 5 cancel each other out, and you're just left with the 3x equals 9 minus 5. Of course, we know that that's 4. I'm just going to leave it as a 9 minus 5 for now. Now, with this right equation here, the plus b and the minus b on the left side of the equation will cancel each other out, and we're just left with an ax. On the right side of the equation, we have a c minus b. We can't combine those because we don't know what c and b are. Okay, so great. What's the next thing we do? If we're solving this 3x equals 9 minus 5, the next thing that we do is we're going to divide both sides of the equation by 3. To get x by itself, you divide both sides of the equation by 3. Well, to get x by itself with this ax plus b equals c equation, we're going to do the same thing. We're going to divide not by 3, but by a on both sides of the equation. To get x by itself, we have to divide by a. So what do we end up getting? On the left, of course, we get x by itself. We have 9 minus 5 divided by 3 on the right-hand side. Of course, you know how to simplify that, and we may as well go the one step further. That's going to simplify to 4/3. On the right equation over here, the a divided by a cancel, and you're just left with an x. That was our goal. On the right, what we have is a c minus b over a. And since we don't know how to simplify, we don't know what c, b, and a are, we can't simplify that any further, and that's your final answer. The only difference between solving the equation with the numbers in it on the left and solving the equation with the variables in it on the right is on the left we can actually simplify our results. We can do the 9 minus 5 divided by 3. On the right we can't. Okay, let's look at an example. Let's say we have the formula P equals 2L plus 2W. And let's say we want to solve that formula for, we'll say L. Okay, so what do we do first? Well, the goal here is to get L by itself. We want this term with the L in it to be all by itself on one side of the equation. So to do that, the first thing that we can do is we can subtract 2W from both sides of the equation. If we subtract 2W on the right, the plus 2W and the minus 2W will cancel each other out, and you're just left with a 2L. On the left side of the equation, P minus 2W is what we're left with. Now, the goal is to get L by itself, and L is still multiplied by this 2. So how do we get rid of that multiplication by 2? Well, the answer is we divide both sides of the equation by 2. On the right, the 2's cancel, the 2 in the numerator and the 2 in the denominator cancel, and you're just left with an L, which is great. That was our goal, was to get L by itself. On the left side of the equation, you have P minus 2W divided by 2. And that answer is pretty good. That's a perfectly good answer. I just want to show you something that you can do with the left side of this equation here. What you can do is you can divide through by this 2 in the denominator. And what that means in this case is you're going to divide the P and the 2W separately by a 2. The reason you divide them separately by 2 is because they're either added or subtracted in the numerator, these terms. So let's just do it. What you can do is you can split this up. You can divide the P by a 2, and you can divide the 2W by a 2. Of course, the 2's in this W term are going to cancel each other out, and you're just left with L equals P over 2 minus W. Now this answer up here, as far as I'm concerned, is a perfectly good answer. I just wanted to show you that you could simplify that a little bit more, or divide it through a little bit more, and rewrite it like that. Let's take a look at another example. Let's solve this equation for y, we'll say. And the equation we want to solve for y is z equals 3x plus y minus 2. Okay, so the goal here is to get y by itself. And there's really only one term here that has a y in it. It's this term right here. So one way to go about solving for y would be to start by distributing the 3 through those parentheses. So let's do that. We'll distribute the 3, and we get z equals 3x plus 3y minus 2. All right, now it might be a little bit easier to get this term with a y all by itself on one side of the equation. What we do first is we're going to add 2 to both sides of the equation. What that's going to do is it's going to cancel the 2 on the right side, and we're going to get a z plus 2 on the left side of the equation. And what we're left with on the right is a 3x plus 3y. Now what we can also do, and we could have done it in that previous step as well, to get this y term by itself again, we're going to subtract 3x from both sides of the equation. And what that'll do is it'll cancel the plus 3x and the minus 3x on the right side of the equation, leaving us with just a 3y. On the left now we have a z plus 2 minus 3x. And to get y by itself, our last step is just to divide by 3. On the right side, the 3 in the numerator and denominator cancel each other out. And on the left, we have z plus 2 minus 3x over 3. And that's a perfectly good answer. Again, if we wanted to, we could divide every single term by this 3, and we'd end up with a z divided by 3 plus 2 divided by 3 minus 3x divided by 3. It's just going to cancel the 3's, and you're left with an x. So I like this answer, and this answer is also perfectly acceptable. Either one works. We've solved for y, so good. All right, let's look at one more example. This one's a little bit more complicated. Let's solve this one for x. And let's say we have this equation. M equals ax plus dx. What you'll notice about this equation is that x, what you're trying to solve for, actually appears twice in the equation. There's an ax term here and a dx term over here. How are you going to get x by itself if it appears in two different terms in the equation? Well, you can't really if it's in this form. So what we have to do is we have to factor. In this case, to get x by itself, we have to factor. What that means is we're actually going to take an x out. We're going to factor an x out of each one of those two terms on the right side of the equation. and we're going to leave the left exactly the way it is. We're just rewriting the right side of this equation. So if you take an x out of this ax term, what you're left with is just an a. If you take an x out of the dx term, what you're left with is just a d. So we've actually rewritten this equation, the ax plus dx part, as an x times the quantity a plus d. You can tell that that's true because you can think of what would happen if we redistributed this x through the parentheses. You get an x times a, which is ax, and an x times d, which is dx. We'd get right back to where we started. So now it's much easier to get x by itself. The goal in this problem is to solve for x, and there's only one x in the equation now, so that's fantastic. However, it's multiplied by an a plus d, this whole quantity. To get rid of that a plus d, since it's multiplied by x, what we do is we divide. That's the worst division sign ever. What we do is we divide both sides of the equation by a plus d. When we do that, the a plus d on the right side of the equation in the numerator and the denominator, they cancel each other out, and you're just left with an x by itself on the right side. So we've solved for x. The left side is m divided by a plus d. And that is a perfectly good solution. Okay, let's get you guys a video quiz. For this lesson, the quiz is going to be to solve for p. And the equation that you want to solve for p is this one right here. A equals p plus p r t. This one's going to be a little bit tricky, so think about it, do your best, see what you can do, hand it in class. Good luck.